All right, so this video, I want to continue our talk about nodal analysis. And this time, we're going to try to see how do we incorporate voltage sources into nodal analysis techniques. Thus far, we've done only current sources and resistors in a circuit to do nodal analysis, but now what I want to do is show you how do voltage sources affect that. And so let's take an example. The best way to see is to start with something we can actually work on. So let's say we have this as an example. All right, so there's our circuit. And what we want to do is, let's say I want to find the voltage at A. Well, everything seems normal except for the fact that we got that 10-volt voltage source there on the left side. Well, let's continue trying to do nodal analysis until we see a problem. So the first thing we do, of course, is to choose a ground or a reference node. Ground will be down here as usual. So that means all of this is 0 volts. Next, we choose our nodes. And a node, of course, is just a location where there's a connection between things. So obviously A has a node. Let's say this is a node as well. Let's call it B for now. So those are the possible nodes in our equation, or our circuit. Once we have that, the next thing we want to do is find the currents that go into and out of these nodes. Well, okay, let's say there's a current coming into B. I'll call that I1. Leaving B, I'll call it I2. For A, I've got that I2 is still coming in, so I2 is still there. I3 going out of A over here, well, that's easy. I already know the current source there, but that's called. And I4 is moving down towards the ground. All right. And then from here, we usually do KCL equations for these nodes. Well, let's look closely at this node B right here. First thing you should understand is what in the world does a voltage source mean? So if you have a voltage source of 10 volts in a circuit, what is that telling you? What it's telling you is, and I'll write just that branch over here, what it's telling you is the difference between these two ends of the voltage source is equal to whatever this voltage is. So if I call this 0.1 and this 0.2, then the voltage at 1 minus the voltage at 2 is equal to whatever the voltage source says it is. Okay? That's literally what a voltage source is. You can think of it like a meter that's sitting there with a little dial or a little window, and it's saying, I'm measuring the voltage on one side, I'm measuring the voltage at the other, I take the difference, and I'm telling you the number that's the difference between those two spots. So if this is true, look at the 10-volt source in our example. That's saying that the difference between this bottom point and the difference and the point B is equal to 10 volts. But we already know the bottom point is the ground by definition. So if for this guy, this point is 0, then that must be that VB minus 0 is equal to the 10 volts. Well, obviously that implies VB is equal to 10 volts. So I already know the voltage at B. So all we have to do is now figure out A. So we would look at node A, and we do his equation. Well, we've got I2 coming in, minus I3 going out, minus I4 going out, is equal to 0. As usual, any of the I's I happen to know, I'll plug in the number, and whichever ones I don't, V over R. So for I2, I don't know the number because I don't have a current source there, so it's V over R. What is I2 doing? It's going from B to A, so it's VB minus VA divided by the 2 ohm source, minus I3. I3 is the 3 amp current source, so it's 3. I already know that. And I4, I don't know. It's just a resistor sitting there, so it's going to VA minus the ground over the 4. Okay, so just like before, here's our equation, 2 unknowns, so I'm going to need 2 equations, but look, we already know VB is 10, so just plug that VB in. So this is 10 minus VA over 2 minus 3 minus VA over 4 is equal to 0. Now we see we only have one unknown, so this is solvable. So we can do it. Multiply everything by 4 to get rid of the denominators. So 4 divided by 2 is 2, so I got 20 minus 2VA minus 12 minus VA is equal to 0. Minus 3VA is equal to minus 8, so VA is equal to 8 over 3. And now we know the voltage at A is 8 over 3. So that didn't really hurt too bad. Given a voltage source, generally speaking, what it's going to do is tell us automatically the voltage at a certain node. In this case, it told us the voltage at node B. We called it B, but that's just a name we gave it. And so there's no difference from what we would have done had there not been a voltage source there. If it looked like this, so if that were the problem, then when we do node A, this current coming in would have been 0 minus VA over 2. Because all of this is the ground. So if the current went from the ground to node A, it would have been 0 minus VA. The difference with the voltage source there, we now know that left side voltage is not 0, but it's 10. So we just stick the 10 in. Now, this is one way a voltage source can be placed into a circuit where we have to use nodal analysis. There is a second way, which is slightly more complicated, which is what we're going to do this time. All right, let's work this example. Let's say we have there's our example. And let's say I want to know what is the voltage at A and at B. Well, we're going to use nodal analysis for this, but, well, before I move on to that, what's the first step? First step, of course, is to choose a ground, so ground down here. So all of this is the ground. All right, next step, choose our nodes. Well, I already have the nodes there. Node A and node B are the only two nodes we need. Next, what are the currents? Okay, well for node A, we have I1 coming in, say I2 going down this way, I3 leaving to the right, and then for B, we have I3 is still coming in, I3. We have I4 going to the right, and I5 going down. All right, so thus far everything's normal. Let's look at node A. Node A, what do we have? We have I1 coming in, minus I2 going out, minus I3 going out is equal to 0. All right, what is I1? Okay, well, I1, there's a current going from the ground to A, so 0 minus VA divided by the resistor is 2. I2, there's a current going from A down to the ground, so it's VA minus 0 over the 4. And then 3. Ooh, I3 is weird. Notice I3, the current goes from A to B, but it does not go through a resistor. So how in the world do I handle this? I don't know the current, because I don't have a current source. So I can't say 10. 10 is a voltage source. It's not a current source. But also I can't do V over R because there's no R sitting there. Now this is why this particular example is so critical to see. This example brings up a technique called Supernode. Now I've already used Supernode as a term earlier, but I'm going to use it in a slightly different way for this one. In order to solve this problem, what we're going to have to do two things. First of all, we're going to have to realize that what this voltage source says. Now, I already discussed it in this particular problem, where I said the voltage source tells you the difference between one side and the other side of the source has a certain voltage. That difference is a certain voltage called the voltage source. Well, the same thing is going to go here. I have a voltage source, and what it says is the difference between point B and point A is 10. So first thing I know is that VB minus VA is equal to 10. Okay. But I have to do a secondary thing. The secondary thing is I have to make what's called a supernode. And what this means is I'm going to take node A and node B, and I'm going to pretend like that's one big node. Okay, so if this is true, pretending like node A and node B are one big node, then what do I have? This supernode is going to look like this. I had a resistor coming into it. I have this resistor going out. I have this resistor going out, and I have this going this way. And all of this is that supernode. Call it whatever you want to call it. We could call it AB. Okay, so pretend like the voltage source isn't there, and pretend like the point A and the point B are the same thing, and now we see what are all the things coming in and out of that. Well, again, this is still 2, this is still 4, this is still 6, this is still 5. We still have the I1, we have the I2, this is I4, and this is I5. Okay, well now, this node A equation I wrote, forget it. We don't need it. Let's do the equation for Mr. Supernode, AB. We have I1 coming in, minus I2 going out, minus I4 going out, minus I5 going out, equals 0. All right, so what do we have? I1. What was I1? Okay, it was the current went from the ground to node A over 2. What was I2? It went from A to the ground over 4. What was I4? I4 is that voltage source of 5, so there we go. And what was I5? I5 was a current that went from B to the ground, and it went through Mr. 6. So there's the equation for the supernode. I still think of this side as the A side, this side as the B side, but it's like one single huge equation for both nodes at the same time. All right, what can I do now? Well, first let me get rid of this denominator, if I can. So the denominator, I need a number common to 2, 4, and 6. I'll call it 12. So I'll multiply everything by 12. So 12 divided by 2 is 6, so minus 6 VA. 12 divided by 4 is 3, so minus 3 VA. 12 times 5 is 60. And 12 divided by 6 is 2, so 2 VB is equal to 0. Well, there's two unknowns in this equation. How do I solve it? Remember this equation we did at the very beginning. Because of that voltage source, we know VB is the same as VA plus 10. So I just plug this in for VB. Now what do I get? Minus 6 VA, minus 3 VA, minus 60, minus 2 times VB, but VB is VA plus 10. Okay, so let me continue over here. So what do we have? Minus 6 VA, minus 3 VA, minus 60, minus 2 VA, minus 20 is equal to 0. Minus 6 minus 3 is minus 9. Minus 9 minus 2 is minus 11. So 11 VA is equal to minus 80. So VA is minus 80 over 11. Now I know what VA is. How do I get VB? Come back here. Minus 80 over 11 plus 10. 10, that's 110. 110 minus 80 is 30 over 11. And so there's VB. And this is how you handle a voltage source that's in the middle. Okay, so there's two ways of having a voltage source in a nodal analysis equation or circuit. The first, which is the easiest, is where it's between the ground and a node. Okay, so here, node B is sitting there, and it's connected to the ground. So all that does is tell you what the value of the voltage at B is. Okay. This one is a little more difficult. This is when the voltage source is between two nodes, not connected to the ground. How do you handle this? Well, first thing you do is take the equation of the voltage source, which is what this is right here. The difference between the big side and the small side is equal to the voltage source. And then you make a supernode equation where instead of having an equation for node A and then a separate equation for node B, you have one single equation for A and B together. And so you have all the stuff going in and out of A and all the stuff going in and out of B all at the same time. And set that equal to 0. And then now you have your two equations and two unknowns. So yes, it complicates it a little bit. It adds a few more steps. And you make your equation slightly differently. But really, the techniques of it, how to build the equation is the same things. You're still doing currents coming in are positive, currents leaving are negative, and so forth. But when you see this, think supernode. So I have a super equation for the supernode, and I'll have an equation for the voltage source. So with this, you now should be able to handle any nodal analysis equation I give you, whether it has voltage sources or not. So definitely be practicing the practice problems and make sure you're doing the homework equations, homework assignments. But get really, really good at this technique, because I promise you the future analytical techniques you learn will require you to still use nodal analysis to solve the problem. It's just that they will allow you to reconfigure the circuit in a way that makes nodal analysis possible. But if you have any questions, of course, let me know as usual. Send me an email and I'll be happy to help however I can. Until next time.